So this is If This Now What, Orchestrating an Enterprise. We're going to go through a lot of stuff today. I'm going to try and really move through some slides to get to the good stuff. Got a couple demos to work through. So hopefully you guys will walk away thinking, wow, those guys at Pearson are doing some cool stuff. So always like a few good quotes from Albert Einstein. In particular, education is what remains after one has forgotten everything you learned in school. Today we're going to go through a little bit of business justification, right? So Pearson is a massive company, and we're going to talk about that a little bit today. But we have to justify what we're going to do, especially when we're talking about doing tooling for our entire development base, which is 400 development teams at the moment. We're going to talk a little bit about requirements, build pipelines, third-party resources in Kubernetes, ingress controller with SSL integration to Vault, and ChatOps. I'm Michael Ward. I'm the Principal Systems Architect of our enterprise platform as a service called Bitesize internally. Some of you may know me as DevOperandi. I have a blog post, www.devoperandi.com. Feel free to reach out, but I will warn you, after today, I'm out of pocket for 2 weeks, so if I don't respond, don't get upset about it. So Pearson, we work for Pearson. We have a small team. Pearson is 171 years old. We've been around for a very long time, and we've gone through a whole generation of different focuses. Originally, we were a construction company, okay? And then back in the mid-1800s, we turned into kind of a publishing company. We've owned companies like Madame Tussauds and The Economist. Again, we're 171 years old, 40,000 employees across 70 countries. And that's really important because our focus in the past has been very diversified. We haven't had any particular focus, but over the last 20 years or so, we've moved towards education. And we've moved from not just printing and publishing education books and providing that throughout the world, but we're also now getting to focus into digital education. What's really important about that fact, and honestly, I've heard some flack about it, is that we're not just interested in providing education to the people that have money. We're interested in providing education and knowledge to those that don't. So that's why we're moving into countries like Africa, so that we can provide everyone in the world a same level of education. They all have the opportunities that they want and need. So Pearson's not small. We've got 36,000 servers, 2,000 applications, and 400 development teams. And when I say 2,000 applications, I mean some of these applications that are not legacy make up 10 to 30 microservices per application. So what we're really talking about are stacks. So this is hard. Every time we have a problem, it's a big problem. There is no small problem in our world. Simple solutions are what we absolutely must have in every scenario. So we really often have to think about what we're doing. On top of that, Pearson is, again, education focused, and that's what open source is about, right? Open source is about sharing knowledge, sharing code, and everyone as a whole contributing back to a community to make us better. And so as you can see, we've released several clients completely open source. We have a Kubernetes pack with StackStorm, which we're going to talk about a little bit more later. We're even going to demo that. And then we've got a ingress controller that we originally wrote prior to the Nginx Alpha being able to manage multiple namespaces. We've also got some integration with SSL and that sort of thing that we're going to really deep dive into. So first off, I planned this for the end of my talk, but I wanted to show you guys something really cool right at the beginning. So we have complete ChatOps integration for building projects in Kubernetes. We have a master Hubot, and that Hubot talks out to and creates a brand new namespace with Jenkins, with a Hubot for each development team and each project. And from there, we can deploy out containers and do all kinds of cool stuff. It also even integrates to the point where we can create brand new Bitbucket repositories or Git repositories, sends you email invites, all kinds of stuff with just literally a forward command. So you guys want to see it? All right. Let's do it. So just to show that we actually have Hubot running, and he is alive right now, you can see we've got the platforms bot up, and Simbas already getting all right. So as you can see, platform bot is up. You can see that in my command line that that my personal platform bot is responding. And I can say create project, KubeCon demo 28, because I've practiced it that many times. All right. So literally just like that, and here, I'll make this a lot bigger for you. So just like that, with literally a forward command, we've created a brand new namespace in our production cluster. We've created a default service account, right? So we don't have service accounts turned off in Kubernetes. That's a big security hole. We've created another Hubot room. So when we create a new project for our developers, we create them their own hip chat room to communicate with. And the Hubot that we're going to deploy into the environment will actually chat back to that Hubot room automatically. And then they can type their own commands through HipChat2 or any other IM platform to be able to say, hey, what do you want me to do? Run Jenkins jobs, all that kind of cool stuff. You can see we created some default build files. Those go into our Git repository. We've created a new Hubot, and we've created a Bitbucket. So let's take a look real quick. And I don't have my email, of course. And you can see that because I put my email in there that I've been invited back to this project. What's really cool is I've also been invited or to have access to the Bitbucket repository. And now I can easily pull down that repo, clone it, and push on to the next thing. We're literally being able to, provided the application is in the right state, we can literally start to bring on applications in minutes, not hours, not months, not anything. So pretty cool stuff. First demo success. All right, business justification. So we're talking about build pipelines and business justification for build pipelines here, okay? Because that's the kind of the central point of this talk. And we went to our stakeholders and we said, so what's important to you guys? Obviously, the business said cost. Developers, management time, ease of use, standardization, compliance, and visibility for security team, and ease of use, agility, and minimal disruption for QA and perf. So within our organization, we have a pretty bad habit of running perf tests against our development environments and really hosing the entire environment and preventing developers from doing anything for the next, 3 days. But let's just talk about the business cost aspect. So we went around to some of our development teams and we said, so how long does it take you to create a build pipeline? Most of them don't even have QA and perf testing and CISO integrated, okay? They were telling us, 3 months, maybe 3 to 6 months with 2 developers to get basically a good starting point. What that amounts to is $50,000 per development team just in development time. When you have 400 plus development teams, you come out to $20 million just in development time. Forget cost of plugins, forget all that extra stuff. This is just development time. On top of that, they have recurring costs, right? Recurring time of developers in order to manage this build pipeline. So now when you're talking about development teams at 400, you're talking $2 million a year just in managing that. So we wanted to reduce that. We don't want our developers spending time with that. We don't even want them to touch Jenkins or Travis or anything like that. We just want them committing code. That's what they're good at. That's what they enjoy. So just because I can, couple quotes from some developers. We spent 6 months solid building a good starting point. We never upgrade Jenkins once stable because we can't get time for it. All right. So stakeholder requirements. We just talked about all the pain points and the various pieces that these stakeholders want. So we turned them into requirements, and we said reduce migration costs, standardization, performance testing, compliance, visibility, ease of use, quality testing, reduce time to manage. But we also had our own requirements, right? If you've ever been in the ops world, which I have, you want this stuff to be geographically distributed. Pearson's massive. We're in 70 countries. We've got data centers everywhere. We can't afford to be single-homed. We have to be geographically distributed. Jenkins, when you've got 400 Jenkins or more machines, they have to be cattle. They need to be self-configuring. They need to be scalable. We need feedback loops back to our developers, and not just hey, it's broke. Hey, it's still broke. We need more information, right? So that's why we've added Hubot into every namespace. So as soon as a Jenkins build fails, it'll communicate back to Hubot and tell us about it. So here was our high-level product design from our director that said, here's basically what we want to do. We want a developer to be able to commit code, continue to develop and iterate on that, run through automation testing, and then run a global deployment to many, many different data centers. And we want it all to happen in under an hour. Not too ambitious, but pretty good when you start accounting for CISO and QA and perf testing and that sort of thing. All right, build pipelines. So there's a real key concept that we need to talk about here, and that's that right now you're seeing Lord knows how many Jenkins servers here, but you have to realize that our developers never touch these Jenkins machines. They literally configure from one place inside their Git repository one time with 3 files, and it works everywhere. It doesn't matter where you are, okay? So you can see we've got AWS, we've got our own private data center on OpenStack, we could be in Ireland. We have different namespaces, console, dev, stage, prod, and there can be any order of that across the entire world. All right. So what we did is we created a standard process by which to accomplish this. Something that would allow our developers to move teams, because that happens regularly when you have 400 development teams, but be able to utilize the same exact development process. Well, another thing is we wanted to prevent our developers from having like one developer on the team that really knows the build CI/CD process. We want anybody to be able to use it, so it'd be simple, right? Excuse me. So what we've done is we've got Jenkins deployed into every namespace and every cluster across the world, every data center. And what happens is it's a vanilla Jenkins, never been configured, never done anything, right? And he automatically gets set up with what we call a seed job, and that seed job reaches out to our developer's repository. That seed job then starts to self-configure it. Hey, I need to be able to develop for Ruby applications or Python or Java. Or, hey, I need to be able to just deploy. I don't have to build anything, right? We want that flexibility. We don't want to build the same image in 100 different namespaces across the world for one application, right? We just want to build it once and then utilize it everywhere else. Also, we need the flexibility of being able to have tests and different sets of tests per environment, whether it's in Ireland or Germany or Singapore. So basically what we came up with, and one of my colleagues, Simas, came up with, along with Jeremy Darling, who's a developer, was 3 simple YAML files. So based off these 3 simple YAML files, anywhere from 10 to 50 lines of code, we can distribute this thing throughout the entire world. I know it sounds kind of crazy, but it works. It's amazing. All right, so let's talk about code a little bit. Let's talk about these YAMLs. So every project, so think of a project as a development team. It can be many different applications within that team, but a project is synonymous for us within a development team. This is actual code running for our console application. Head is higher ed. We have a base image, so we're telling Jenkins, hey, we're going to deploy for Node.js 4.2.3. So now Jenkins knows to go out and get Node.js 4.2.3. Oh, by the way, we have some components here. Console server, console UI, console stub. And these are all components of a single microservice build. So our developers requested the flexibility of not just creating microservice, but actually being able to take that into smaller bits of code so that they could manage it more easily. And that's what we've done here. We call them components. And then down here at the bottom, we've said we want to be able to specify what the runtime command is, right? All right, so that was application.yaml. Pretty easy. Build.yaml. With build.yaml, all we're doing is specifying a set of dependencies by which we can configure our Jenkins machine. We're specifying what the name of the components are that we're going to create. We're specifying the repositories down here that Jenkins needs to reference. So now we're not just hitting one repository, we could hit 100. It doesn't really matter. We can just keep adding to this list as our developers see fit. Actually, the developers have complete control over this. So we're basically telling Jenkins, where are the other branch and repo locations that I need to be aware of? We're then telling Jenkins how we build this, and then we're also telling Jenkins a little bit more information about another piece of code in this example called console stub. So then we have one more YAML file, environments.yaml. What's really cool about this, and I didn't really display it, is that actually I did. It's right there, next environments. So in this case, we're going to build for our development environment. It's going to be console test. Our next environment is staging. So what that means is after dev has launched, we'll automatically route on to our staging environment and build there too, or deploy there and run a completely separate set of tests. Pretty nice. We've defined a service, very much synonymous with Kubernetes services and ingresses because we run ingress load balancers on our cluster. And we're basically defining a couple environment variables. We can define a port. We can say, okay, here's console dev pearson.com. That's going to be our publicly available endpoint. And this means that Jenkins automatically builds our ingresses for us, which gets added back into our ingress controller. Okay? And then we've got tests. So we don't want to allow our QA and CISO and perf testing teams to be left out of the process. We want them to know that they always have a seat at the table. Okay? What's really cool about this is all we do is specify another repository, another branch. We can provide shell commands. We can point to an API endpoint. We can do anything. All the devs and CISO guys, all they have to do is say, hey, developers, this is where you need to point to for your tests. Pretty rad, because now QA and CISO, they have complete control over how that application is going to get tested. Is it unit testing? Is it integration testing? Is it end-to-end testing? Are we doing breach management testing? It doesn't matter. The developers don't even have to know about it. All they have to do is say, hey, developers, point to this test location, and we're done. It's that easy. All right. So what requirements have we met with this? We've met geographic distribution because even though we may have the same application across many different clusters, it's based on the namespace. So if we have console test as an example, console test reaches back to the same Git repository and says, hey, I'm console test. Tell me what the hell to do. They're self-configuring, obviously, because now they've been told what dependencies to pull from. They're standardized, meaning across 400 development teams, really the process is pretty similar. The only difference is the commands, right? It's pretty easy to use, although we're working on that. Again, they're cattle. It's scalable. So we don't have this big monolithic Jenkins machine per dev team, right? We might have 12 Jenkins machines across one dev team, but those Jenkins machines can be, a couple hundred megabytes in size, because they may or may not be doing much. What's even great about that is those Jenkins machines, what we're working on right now, if you have a skill set in this area, is we're working to scale out that automatically based off of the load that's generated in this configuration. So if you guys have some insight into that, we'd love to hear from you. And then we reduced migration costs. One of our developers, actually the developer that gave me some of these comments that you saw earlier, he was able to help another team come on in like 15 or 20 minutes. 15 or 20 minutes to migrate from an existing virtual environment to getting started building on PaaS. That's pretty rad. I mean, how many people can say that here? Hands? All right. I think it's pretty rad. All right. Base builds. So in order to make our environment fast, what we've done is we've created what we call base builds, right? And we've said, basically, we're going to have Java and Python and Node.js and PHP and whatever applications our developers want to do, and we're going to provide them as a base Docker image, okay? So Jenkins, it still goes through our entire build process. We're still developing these things, right? Or excuse me, this is done, but what I'm saying is we still go through an entire development process and testing and QA and security on all of these base images. That way, when security says Node.js 4.2.3 is ready, they've already signed off that from a compliance perspective, they're happy with that. Is that kind of cool? I mean, how many of you can say, hey, CISO's already signed off on what I've done and I haven't touched anything yet? It's pretty awesome. So then after that, obviously it goes through our normal feedback process, back to Hubot, back to our core team. But Jenkins can do all of this stuff in an automated fashion. And again, what's great about this, these are just base builds. These are not the application we're gonna use. We're just using this as a method to secure our base infrastructure so that we don't have to do as much testing when we do our app level development. If CISO and QA have already bought into these base build images and said, hey, those are good to go, then really all they have to do is test the delta of the application. And of course, any additional libs that are added onto it. And we don't prevent that. That's totally fine. All right. So after we get done with the base build, as you can see, we just kick off Nginx 117 to our registry, and it's ready for consumption. They can just specify it inside of their YAML, and they're good to go. So what have we done here? We've created a standard process across the enterprise by which to create and level set base images. We've ensured compliance because as long as it passed the test that the CISO guys and the QA guys have set forth, we're good, and we've determined we have at least a minimum base set of security involved. Kind of nice. All right, so app builds. So app builds are very much similar to base builds. The only difference is that we require a base image here, in this case, Nginx 117, that we've already verified and we've determined that it's met a given security and QA and perf testing requirement. Then we inject our application code in here. What we do currently is in the form of a deb package. So all we do is take a series of deb packages, plop them into the right directory. So we've created a standardized directory format. And we throw them in. Jenkins populates that as another application image and then tags that and throws it into our registry. So what have we done now? We've increased speed because we're not trying to build an entire base image and the application image at the same time. We've included performance testing. We're now scalable because once it's in the registry, we can just deploy that image from anywhere. We've met CISO's compliance and quality testing. CISO and performance are all kind of built into the environment. Man, I feel like I'm moving through this really fast. How much time do I have? All right. So what else? So we've really been doing a lot of amazing things inside of our team. One of these is managing external resources with Kubernetes. So what that means is there's something called a third-party resource in Kubernetes, and basically use StackStorm, which is an open source platform, and we're allowed to or able to watch the Kubernetes API to create new cool things. So it could be databases, it could be anything you want, but what's really cool about this is we're managing this from Kubernetes. So imagine being able to deploy an RDS database and saying, I want RDS, I want it to be MySQL or Aurora or whatever you want, and I want to be able to determine the size, how much storage it has, everything, and all you do is push a little bit of code up to Kubernetes, and the rest just handles it for you. It then takes that data, and I don't have a good slide for it. It then takes that data and populates into our dynamic configuration store console by HashiCorp, and it populates the secrets into Vault, so when our applications spin up, they automatically ingest that as environment variables. Developers don't even have to know what those endpoints are. All they have to do is call the same generic environment variable forever. So you guys want to see that? Kind of rad, huh? All right. Don't fail me now. All right. So let me show you what that looks like real quick. So as I mentioned, this is just one config file. We're saying, hey, I want a database. I want it to be MySQL. Currently, it's a third-party resource. We give it a little bit of a description. We tell it which version that we want to run on. All right. So we currently have one database running, but we want many, many, many more. So let's go ahead and create that sucker. No. Oh, man. Doesn't this always happen? Right when you need it. It only worked like 100 times right before I got up on stage. Apparently I didn't make a sacrifice to the demo gods today. Excuse me 1 minute. Ignore everything you're seeing. Oh, well, no wonder. I think I lost my, ooh, good. Oh. Oh, that's what I get for trying 2 demos in one day, right? All right. So while I'm working on this, who has questions? By the way, I got a pass, said delegate on it, and they scratched that out and wrote speaker. I said, this is excellent. I'm just going to delegate my speaking engagement to somebody else. It's brilliant.
Does anybody have questions? Yes. Okay, hang on. We'll start here and then go there.
Adoption.
Yeah.
So you've got 400 development teams
Right.
on the old platforms.
Uh-huh.
You know, taking carrot and stick into mind. Did you have to kind of move any of them across with a bit more of a stick than a carrot?
So no is the answer. Honestly, I think this is mostly a human element. Some development teams don't want to change, and that's perfectly acceptable. But what we did was we brought them in early, and we started warming them up to it. You know, it's kind of like, hot chocolate in the microwave. It takes time to warm them up to it. And then what we started doing is again, we started investing in them, and we said, so what do you want? What are your frustrations? How can we help? And they gave us what they thought were impossible frustrations, right? That no one would ever do, no one would ever complete. And so we spent a lot of time in that, and we said, okay, how can we solve this in a way that would really be meaningful to developers? And at that point, it's kind of like that guy that stands out in Woodstock and he dances for like 80% of the video, right? And finally somebody says, well, that looks fine. I'm going to run out there with him. And they got two people dancing for another 90% of the time. And then on the YouTube video, like the entire swarm of 4,000 people is having a mosh pit in the middle of Woodstock. It's kind of how it is.
Community for the win.
Anything else?
Yeah, I'm here. Hey.
Oh, hey.
So I wanted to know how you manage upgrading Jenkins, since I've seen it's so easy to spin a new instance, right, and a new namespace.
Mm-hmm.
How are you managing, since Jenkins has a sad history of remote code execution bugs, which is kind of natural given how it works?
Yep.
How do you manage upgrading Jenkins across the fleet without disrupting developers' work? Because
that's
so many
huge,
instances.
Right? That's why developers never upgrade Jenkins. So what we've done was, as I mentioned earlier, Jenkins is self-configuring, okay? So regardless of what you're running, it self-configures itself. So we can literally just kill off a Jenkins pod. When it comes back up, it reconfigures itself. Now, we use Jenkins as a base image in our process. So what that means is before it ever gets to our developers, we've already run through a series of testing against it. We can even incorporate some of our developers' YAML files that I was talking about earlier, and we can say, is this going to run on top of this? Okay, because we have the ability to steal those, and we don't have to have access to the repositories. The only thing that does is Jenkins, and then we can duplicate that set. The other piece is, and that's an excellent question, it's going to lead into something really cool. We've just designed a process by which to upgrade, and we have two different upgrade paths for our infrastructure. One is Kubernetes-based infrastructure. The other one is the pods-based infrastructure. So essentially, we're building out something really cool because we have what we call kind of global services, like Jenkins is a global service, Hubot is a global service, caching is a global service, all these different things, and we need to be able to upgrade those efficiently across a distributed environment. So what we're doing is we're creating what we call a brain to enable that, and essentially it will upgrade everything for us. And we can do that at any time. We can set schedules. We can do all kind of cool stuff. But because Jenkins is literally just an image to us, we can determine very easily if it's going to be successful for our developers. Yeah.
So we have 3 or 4 more minutes. Do you want to close up or take another question?
Well, since my second demo failed utterly, I'm happy to take questions.
All right. Awesome. We've got one way here at the back, so I will go chase that way.
What are you doing for your networking?
Within the Kubernetes cluster?
Yes.
Currently, it's Flannel, and it's worked quite well for us. But we're going to be moving on to other things. We saw Romana for the first time here during this conference, so we're going to take a look into that. And we've seen some other networking pieces that we really want to take a deep dive into. currently we don't allow things. For example, our registry is actually a pod within our cluster that that other pods, or that Kubernetes calls in order to deploy pods. So we don't really expose much outside of our cluster. As a matter of fact, I think I have a good slide on this. So within Kubernetes, or within we're currently in AWS, and we have the capability of deploying into OpenStack, but we develop our tiers. So we've got a load balancing tier that is spread across multiple AZs. All these are in auto-scaling groups, by the way. All of our minions, all of our master, and what we call our load balancing minions are all in auto-scaling groups. So as you can see here, we've got our load balancing minion tier, and those are the only machines that have any exposure to the internet. All of our back-end machines here have zero exposure to the internet, and zero direct exposure at all. So we've reduced our footprint significantly. But yeah, Flannel is currently the way we're routing. We've tested some other things, but that's currently what we're using. Real quick, I do want to talk about something really cool that Martin Devlin on my team created, and it's freaking brilliant. So you guys all have heard about the Nginx Alpha controller that can route traffic and listen on 80 or 443. The problem with that is SSL generally has been painful, to say the least. I've heard some other guys at the conference saying they're just adding SSL certs to Kubernetes secrets, which is fine, but Kubernetes secrets are really just an obfuscation of the data. They're not actually encrypted. So that was a problem for us because our compliance guy said, no, that ain't going to work. So what we've done is we've automated population of SSL certs into HashiCorp Vault, right? And then whenever we create an ingress controller, which again is deployed through Jenkins, we create an ingress. Our Nginx controller pulls that as a backend, and then we have a little Go kind of program or agent that runs on those pods that then pulls in the SSL cert based off the domain name. So what's really cool about that is we can now manage our SSL certs from a secure store and Vault. And by the way, I didn't really mention this very heavily, but please understand that the vast majority of what we're doing is entirely open source, or we will be open sourcing it once our code looks a little better.
How can people find that open source?
I'm sorry?
How can people find that open source?
Yes, right here.
Fantastic.
Great lead in. So we've done a lot of integration. We created the first Kubernetes pack for StackStorm, which is an IFFT or event-driven automation platform, and it is inside the public contrib. Again, Martin Devlin created the SSL integration. We're currently submitting that as a pull request into contrib for Kubernetes. This Jenkins build pipeline here, we've got to turn it into a plugin so it's really easy installable for you guys, but we'll be making that open source as well. And then we've got our ChatOps integration that Simus and I do are built, which we'll be open sourcing very soon. So stay tuned. Again, my blog is devoperandi.com. I post a lot to there and reference a lot of these projects, so feel free to reference that, and we'll definitely post there as well as our Pearson blog so that you know once we finally open source this stuff.
Okay, we have one super short question.
Sure.
Are you going to post your slides on your blog?
Yes, we will. We'll post the slides on the blog. Absolutely. Awesome. One quick thing, etcd restore, okay? So we currently have the ability to restore etcd from files into a completely new cluster. So we can do A/B deploys of clusters. It's not pretty yet, but it is working. But with the stuff that Brandon Phillips was talking about, we'll be routing that way. So forget you ever saw this slide.
Awesome. Thanks very much.
Thanks.